You ever wish you could just guess better? That you could know exactly how many gumballs were in one of those big things they have at grocery stores? Well, I can't teach you how to do that, but I can teach you how to get really, really close to it. In this video, we're going to go over how to guess smarter and better using math, more specifically, expected value. We'll learn how to quantify guessing and get as close as possible to the largest possible amount of data. Right? So let's start simple. Say my friend Joe is a bit down in the dumps. He feels incredibly unlucky because every week for a year he's bought a lottery ticket and he hasn't won a single thing, not a single cent. He's pretty upset. Is he unlucky? Some people might say yes. Some people might say no. But we can quantify this down to a single number. Right? So let's say Joe buys tickets for a small lottery. Right? It's worth around $500,000. It's a lot of money, but it's not mega millions, right? And 10 million people play this lottery every week because who doesn't like money, right? So the earnings per person for each lottery is $500,000, the total amount for each lottery, divided by the number of people who are in each lottery, and that comes out to 5 cents, just 5 cents for each lottery. So the average earnings per lottery is just 5 cents, right? So if Joe plays, if Joe plays the game, if Joe buys lottery tickets for 52 weeks, which are how many weeks are in the year, right? That his expected earnings, given the average earnings per lottery, comes out to about $2.60, which doesn't seem that bad, right? Because $2.60 is not that far away from what he actually got, which was $0.00. So we can say, well, he isn't that unlucky, right? He got kind of around what we would expect him to get given this, average value. And this is the basis of what we call expected value, right? The average amount that any one person can expect to get from something or event or probability, right? Wherever the result depends on chance, right? To find the expected value, all you need to do is take all the possible outcomes, multiply each by the probability of it happening, and add up the results. To put it in a math way, right? We'd say the expected value, which we just call this funny little Greek symbol, because of course math is based around Greek symbols, is equal to the sum of every value multiplied by its probability, right? Now, if that all looks like gobbledygook, don't worry. We'll get to it in a minute, but let's start with an example, right? So I'll just put this up in a corner and we'll digest this. But let's start with an example, right? Say I'm rolling a dice, standard 6-sided dice. What's my expected value then? Well, I can get a 1, I can get a 2, I can get a 3, I can get a 4, a 5, a 6, right? Those are all my possible options when I'm rolling that dice. I can't get a 7, I can't get a 0. Right, now what are the probabilities? Well, it's standard, so each of them are equally probable. So there's a 1 in 6 probability that I could get this. There's a 1 in 6 probability that I could get this. A 1 in 6 probability I could get this, and so on and so forth, right? Now, we're going to multiply each value by its probability and sum them all up, right? So 1 times 1, 1/6 is 1/6. 2 times 1/6, 2/6. 3 times 1/6, 3/6, and so on and so forth. Right now, I'm just going to do some simplifying, so that becomes 10/6. This is 5/6, and that's 5/6. So that's 10/6 plus 1/6, right? We simplify that out, we get 21/6, which I'm going to do some further simplification. Divided by 3, I get 7/2. 7/2 is 3.5. So, according to this, I would expect my average, my expected value, right, would be 3.5. Now, it's important to note that the expected value is not necessarily the most likely result. As you can see, it'd be pretty unlikely, honestly impossible for us to roll a 3.5, right? But if we were to average out all our scorings, we get around a 3.5 if we were to add them all up, right? That's the average expected value that we can get. Not the exact value, just the average, right? So let's switch up our example, right? So we're rolling a dice, but let's say it's unfair. We've weighted it. We've done some nasty little cheating. What is our expected value going to be now? Let's just say, instead of 1/6 evenly distributed, let's say this only has a 1/10 probability being 1, 1/10 probability being 2, and so on and so forth, until we get to 6. And 6, we did some conniving and cheating, because this has a 50% chance of being a 6 if we roll this. That's crazy. We really did weight this die, right? So what's our expected value now? Now that we have a 50% chance of rolling a 6. Well, let's multiply each value by its probability and then sum them up, right? So 1 times 1/10. 1/10, these are all 1/10, so I'm just do 5 times 1/10 plus 3. Oh wait, no, shoot. Yeah, sorry. We're going to do 1 plus 1/10 plus 2 1/10 plus 3 1 over 10 plus 4 over 10 plus 5 over 10 plus 3. It's a very, very big number. You add them all together, our expected value is now 4.5. Now that's a lot higher than 3. That's a fair bit higher than 3.5. So we can say, wow, we really did bump up that expected value to more than we expected. So as you can see, weighted dice really can change what the average score that you're going to get would be. All right, and if you say, okay, dice rolling, I guess that's useful, but I don't really like to gamble. Don't worry. Let's apply it to the NBA. Now, I hope you like the NBA, but let's say, LeBron James is throwing shots, right? And I'm his manager, and I want to know, hey, is this guy good? Is this his value? Well, let's say 43% of the shots that he takes are worth 2 points. 6% are worth 3 points, and the rest are worth 0 points. He just misses, right? So, the question is, what's his expected value going to be, right? If LeBron James takes a shot, what's close to the value that it'll likely be, right? But we need to use expected value, right? So let's write it in a more easy to understand form, right? So 2 points, it has a 0.43, right? That's just 43% converted to decimal, all right? 3 points, right? That's 0.06. That's 6% converted to decimal. Then 0 points, right? And to find the percentage that we need to find here, we'll just add these two percentages up, which is 0.49, and subtract them from 1. That's 0.51. So I have a 51% chance. Well, LeBron has a 51% chance of just missing the shot entirely. Maybe he's having a bad day. Who knows? Still, not entirely great, but we can work with it. Right, so what's expected value? Well, again, I multiply each number by the probabilities. So, over here, that's 0.86. Over here, that's 0.18. And of course, 0 times anything is flat out 0, right? So, what does that turn out to be? That turns out to be, if we sum them all up, to be 1.04. So if LeBron James was shooting shots, we would expect him to get around a point if we were to average up all the shots that he'd make. Not great. So maybe we should sell LeBron. Maybe he isn't that worth it. I'm sorry, LeBron fans, if this is an example that you are particularly upset by. If it helps you imagine Michael Jordan or whatever basketball player you really, really hate. Because 1 point isn't the greatest. right? And finally, we can use expected value to turn us a pretty nice profit, right? So let's say we're buying stock in companies, and now let's say the probability that the stock will fail and they'll get $0 is a 50% chance, right? So 1/2, right? Be worth $1, that's 1/3. Be worth $10, that's 1/6, right? Now, what price is it worth it to buy a share for, right? Is it worth $5, $10, $2, no dollars, right? Well, to answer that question, we need to find the expected value of that stock, right? Because that tells us the average profit that stock's going to be making, right? And so whatever that expected value is, that's what we should be buying the share for. So let's find that expected value. 0 times anything is, of course, 0. 1 times 1/3 is 1/3. 10 times 1/6 is 10/6. And let's go ahead and simplify that fraction. So I'm just going to make everything into 6 on the denominator. So that's 6 over 2 plus 10, which is 12. 12 over 6 is 2. So if I'm buying that stock for $2 or less, it's worth it. If I'm buying it for $2.50, for $5, for $10, it is not worth it. The expected value is going to be too low compared to what I'm buying it for, right? So we can use this expected value to put a max cap on what we should be paying for that stock. We can apply this to other things too, like how much do you pay for a given service if you know the probabilities of it working or not working, right? The expected value provides that max cap of what is it really worth? What profit is it most likely to turn? And that is what you should be using. So, expected value. It can teach you how to quantify your luck, how to best cheat on dice or in other board games, how to know the exact worth of a variety of sports figures, and to make you some profit off of investing. I hope you found that fun and interesting, and I hope you have a great day.